Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi back to the panel, Dr. Nur Ain and Puan Rashida. My name is Engku Mohammad Shah Hakimi, bin Engku Mohammad Bunia. And today, to complete my final year project 1, I will present to you guys about my project, which is wildfire surveillance system for peat soil area. My supervisor for this project is Dr. Azwin binti Buhari, and my co-supervisor is Technologist Maizul bin Ishaq. We'll proceed to the first subchapter, which is introduction. Okay, this project is focusing on the surveillance system to prevent wildfire, especially in peat soil forests or peat soil area. And then by placing a surveillance system in the forest, the wildfire risk can be reduced since the sources of the fire can be detected early, and the fire department can take an action way more faster. And then the project is made up of 10-volt solar panel as the main energy sources. So it is using the green energy. And then I have installed the heat and smoke sensor, which is the DHT11 sensor, and for the smoke sensor, I have used MQ2 sensor. And the function of the sensor is to collect the real-time data of the soil and the data of the air. And then the data will be processed by the microcontroller, and the data collected, such as temperature, smoke, and location, will be sent to the user by using the GSM module, which is SIM900L, using the GPRS technology. And the GSM module is merged with the Blink app, which is a mobile application to make the user interface is way smoother. And then for the problem statement. For the problem statement, first of all, the wildfire relating for the peat soil forest is one of the most unresolved disaster in the world, especially in the South Asia country. So one of the reasons, instead of natural, there is also human interaction in wildfire causes. One of the reason is transmission line fault, which produce a spark. The transmission line fault will produce spark and ignite the dry peat of the forest. Thus, a smart safety surveillance system is a good countermeasure to detect yearly wildfire spread and preventing power outage. So, as we can see right here, one of the reasoning behind the wildfire is the spark from the transmission line fault. As we can see right here, based on the CNN news, California's second largest wildfire was sparked when power lines came in contact with a tree, based on the California Fire Department. Okay, and then we'll proceed to the objective of the project. There is 3 objectives for this project. First of all, to investigate the real-time data of smoke and temperature of the peat soil as a preventative measure from wildfire. And the second one, to develop a wildfire detection system for peat soil forest area. And then for the third one is to verify the performance of the proposed system in a real situation via experimental setup. To achieve this objective, I have set a few project scope. So the first project scope is the smart system is made up of microcontroller to process the data, which is I have choose Arduino Uno since it is much way cheaper. And then there is 2 types of sensor to collect the real-time data for the temperature, which is the NTC or the HT11 temperature sensor, and the smoke sensor, which is MQ sensor. And then the data will be analyzed and processed by the microcontroller, and then it will transmit it to the Blink app by using the GSM module, which is the SIM900L. And then when the sensors detect the presence of smoke and a rise of temperature if the carbon monoxide level is high and the temperature is more than 50 degrees Celsius in the soil, the sensor will trigger and the signal thus the microcontroller will be processing the data, thus sending the alarm to the user through the GSM module. And then the alarm will be triggered to notify the people nearby by using buzzer. And then there will be a buzzer in the prototype to notify nearby people if there is people in the forest that there is sources of fire in the forest. And then a message also will be sent to the user to make them check the Blink app. And then the user also can check the current temperature or real-time temperature and smoke presence by using the Blink app for a safety inspection. And then the prototype is built to become a standalone device in the forest. So the prototype will be easy to access and troubleshoot. To ensure the sustainability of the project, the 10-volt solar panel is used as a power source with the help of a battery pack. So the prototype will be solar powered, and the solar panel will charge the battery pack continuously to power up the Arduino. Okay, we'll proceed to the literature review for this subtopic. I have made a few research based on the previous project, and there is 5 previous which is a bit similar to this project, and I have put a few disadvantages and advantages for this project, and the advantages have been applied in our current project. Number 1 is IoT-based environmental monitoring system for Brunei peat swamp forest. The disadvantage of this project is it is way more expensive, but the advantages is it has many sensors. Why it is so expensive? Because this project need a server to maintain the data collected from more than 7 sensors. And then the improvement that have been made for my project is the project must have more than 1 sensors to collect more accurate data. In our project, we have 2 sensors, which is the temperature and the smoke sensor. For the second previous project is IoT-based intelligence for fire emergency response system. For this project, the disadvantages is it doesn't have enough sensor and the function is very limited. But it has have a proper apps that can merge with smartphone. And for the project improvement, the smartphone apps will be developed and it will make the project much more user-friendly. And then for the third project, we have design of a home fire detection system using Arduino and SMS gateway. Okay, for this project, the range of the sensor is low, but the advantages is the circuit is cheap to develop. Okay, so we need for the project improvement, we need to choose the sensor correctly to have we have to consider the range of the sensor. And then for the fourth one is IoT-based forest fire detection system. For this project, it is way similar with my project, but the only differences is it doesn't use renewable energy, and it has Wi-Fi, and it is way easier to build. But it is not suitable to put in the forest since it doesn't use renewable energy, and it can't be a standalone device in the forest. So the project improvement is the application of green energy, which is solar energy, is needed. And then for the fifth one, wireless sensor network for wildfire detection and notification via walkie-talkie network. Okay, for this, the technology used is so outdated since it uses GPS mapping, and then but it is cheap and fast detection. So for the project improvement, we need to make our To make our project much more can be commercialized, the project must be cheap and easy to troubleshoot. That's why I have choose Arduino Uno as my microcontroller for this project, since it is cheap and easy to troubleshoot. And then for the project development. Okay, in this project development, this is the project system block diagram. We have DHT11 temperature sensor, MQ gas sensor for the input, and then the data collected by both, of this sensor will be transferred to the Arduino Uno, which acts as our microcontroller. And then the Arduino Uno will be powered by the 10-volt solar panel. The Arduino Uno will collect the data, and if the data is there is threshold value. If the temperature is higher than 50 degrees Celsius and the ppm for the carbon monoxide concentration is more than 250, thus it will trigger the buzzer and it will light up the LED to notify nearby people. And then at the same time, it will send the data to the GSM 900L, and the GSM 900L will send the alarm by the SMS, and it will show the current location in the Blink apps. Okay, this is for the system flowchart. We have start, and then Arduino Uno in standby mode. And then both of the sensor MQ6 will detect the carbon monoxide, and the heat sensor will detect the temperature. If the carbon monoxide is more than 250, Arduino Uno, if yes, Arduino Uno will trigger the buzzer. And then it will send the SMS and the data to the user using the GSM module. SMS will be received by the user, and at the same time, the data will be shown in the Blink apps. But if the carbon monoxide level and temperature is in normal condition, the user still can see the real-time data of the prototype collected by the sensor, since the Arduino will send the data using GSM, and it will be shown to the Blink apps. But there is no alarm, and there is no buzzer sound, and there is no LED will light up, since the sensor doesn't detect any fire presence. Okay, and then we'll proceed to the preliminary result. For our preliminary result, I have designed this schematic circuit and the circuit connection. As we can see right here, we have Arduino Uno, we have LCD 16x2, and then we have the buzzer, the LED, the DHT11 sensor. This one is the GPRS module, and then this is the SIM 900L and MQ sensor. Okay, this is the 3D layout design. The box right here will fit all of the circuit that will be built. And then there is a solar panel that much more slanted in a few angle, and to increase the efficiency of sunlight that will pass through the solar panel. And then a hook will be installed, so the positioning of the prototype can be installed at the tree. And then for today's conclusion, this presentation has discussed the yearly development of the wildfire surveillance system for peat soil areas. The location and the implementation of the project have been discussed, which can be located in the preserve forest near the transmission line. Moreover, the surveillance system can help the fire department to control the wildfire by detecting the early stages and preventing the power outage. Future development of the project can be made by increasing the functionality, especially to help the biodiversity conservation by applying the human technology. This is a project Gantt chart that has been followed through the project timeline. And then this is the references that have been used to guide this project. Okay, that's all from me. Thank you very much for listening.